Hello students, this is Dr. Ben. I'd like to take a few minutes to work over an example problem out of chapter 4 towards the end of the chapter. It has to do with the topic of free fall. So free fall occurs in a vertical direction, and this problem is about an object that moves in that way. It's about a brick that falls off of a pallet as it's rising upwards at a construction site. So this problem consists really of only one part, which means we need only 2 points of interest when we draw our pictorial representation of this problem. So why don't we go ahead and do that? So we'll set up that pictorial representation on a vertical number line. We'll put the origin to be on the ground. The initial position of the brick when it falls is at the top. We'll call that point number 1. And then point number 2 is where the brick is when it hits the ground. We'll have our variables y1, v1, and t1, and then y2, v2, and t2. And then between those 2 points, the brick is only influenced by gravity, and so the acceleration of gravity is downwards, and that will actually be negative in the coordinate system that we picked. One interesting thing about this problem is that the initial velocity of the brick is given to be positive. We're told that it is rising as it falls off of the pallet. So we go ahead and make our table of what we know and what we want to find. So the value of y1, the initial position, is given to be 22 meters. The value of y2 is equal to 0. The value of delta t for this problem is 2.5 seconds. We can go ahead and set t1 equal to 0. And in our problem, the acceleration due to gravity is negative g in the coordinate system that we picked. And what we want to find in this problem is the value of v2. Alright, so all of the kinematic equations contain the initial velocity of the object, and so it's going to be hard to make any progress on this problem without figuring out what that initial velocity is to begin with. So we're going to have to do that by using one of the kinematic equations, and if we look at the information that we have, we know the distance traveled and the time that it takes and the acceleration. So the first kinematic equation that has the position, the velocity, the acceleration, and the time would probably be the most useful. So that would say that y2 equals y1 plus v1 times t2 minus t1 plus 1/2 a sub y times t2 minus t1 quantity squared. Alright, and we've got all the numbers that we need for this expression except the value of the initial velocity, which is what we are trying to find. So we go ahead and substitute. We would have 0 equals 22 plus v1 multiplied by 2.5 plus 1/2 times minus 9.8 times 2.5 quantity squared. So we take the 22 to the left-hand side, minus 22, and then we add to it the numbers that are on the right-hand side. So we have 2.5 squared times 9.8 divided by 2. So that's 23, oops, I made a mistake there. 2.5 squared times 9.8 divided by 2 is 30.63. So we'll just round that to 30.6. And then we divide that by the 2.5 that's in front of the v1. So that gives us v1 equals positive 3.5 meters per second, and I'm pleased to see that that sign is positive, which agrees with our analysis that the initial velocity of the brick is upwards. Alright, so now that we have that initial velocity, we can use any of the remaining kinematic equations to find the final velocity. The simplest one would probably be the equation with velocity, acceleration, and time. So if we apply that to this situation, we have v2 equals v1 plus the acceleration multiplied by the time interval. So we can just solve this problem completely numerically. So we have positive 3.5 minus 9.8 times 2.5 seconds. And we get our trusty calculator out, and that turns out to be equal to negative 21.1 meters per second. And so that points in the downwards direction, and again, that pleases me because in the coordinate system that we picked, the brick is traveling downwards when it hits the ground, and so that should be a negative velocity. Alright, so we'll finish our problem by checking our units. We have the velocity measured in meters per second. Significant figures, we have the same number we started with. The direction of this quantity is downwards, which we're happy about. So I think that we accomplished our goal.